So we are welcome to another edition of this weekly program. So today we are going to be discussing and looking into dealing with missing data. So under our important clarification series, with the sub-theme of a quick overview of machine learning modeling, and the modeling process. So if we remember that we always remind ourselves about this process. This is the iterative process of machine learning. See? So the iterative process of machine learning, which is here. So we are dealing with data preparation. We are dealing with this iterative. So you have that particular luxury. So, and we already discussed that there are several pre-processing activities. Last week we discussed pre-processing and what are the activities that are associated with them. And we concluded that the most important pre-processing that is very important in most cases is the missing value. So while other pre-processing could be optional, subject to the nature of the data set. And following the principle of let the data speak, we discourage us from being too much on pre-processing. Otherwise, you may end up having your data already mutilated. So you are not dealing with real data anymore. So we only do which part of the pre-processing activity that are very, very important. Otherwise, do the little you can in the pre-processing under data preparation, like missing value treatment is very, very important. Very, very important. So after that, you do the modeling, then you check the performance. You can go back here and do a hyperparameter optimization. You may also go back to do feature engineering, creating new feature, combining feature, transforming feature, or you may have to go back to your data preparation and do other things. However, always remember that do the minimum possible, model it, let the data speak. If you get yourself too much involved in pre-processing, in fact, there's an opinion that 60% of the time for your modeling should be spent in pre-processing. You see, unfortunately, this may lead to losing the raw data, the original data that is closer to reality. Let the data speak. Always remember this principle, because sometimes some pre-processing could be counterproductive. So like normalization, so it's not always that normalization gives you good result. We've had cases where normalized data produce bad result, but when we remove the normalization, then we got better result. So we have to bear this in mind. So now, we are dealing with missing data and the treatment today. So we're going to look into what is missing data, then what is missing data, then what are the causes of missing data, and why is it required to carry out missing value treatment. So hopefully we should be able to cover this by the grace of God. So hopefully next edition we'll be looking at the method for treating missing value. We'll leave them out hopefully, and then we can deal with each of them in detail another time, subject to the availability of time. We mentioned this in the past that usually we have the dream versus the reality. That how is your data? This is what we are always expecting. So everybody always look towards having this kind of data. This is the dream of everyone. However, in reality, you may have data that spans several types of data, say log file, audio, and the likes. But you have to find a way of taking your data back to this machine learning ready data set so that you can model it. So we assume that, okay, we already have our data in the normal form where that is better. So now looking at the data cleaning, these are the major tasks in data preprocessing, which we covered extensively last week. Look at one of them is data cleaning. Under data cleaning, we have the missing value treatment. So this is what we are looking at today. We have noise treatment, outlier treatment. Hopefully, we also have the opportunity to discuss some of these other things at that time. So let's move to missing value now and see what necessitates missing value. What can necessitate missing value? Where are they coming from? Can we really avoid it totally? And what are the possibilities if we want to avoid it totally? So now, so this is missing data and its sources. So what are the sources of missing data? Why do we have missing data? We say missing values, they are representative of the messiness of real world data. And there can be multiple of reasons why they occur. So it means it's natural to have missing value. Some of them could be due to human error during data entry. You just have somebody either is careless, or sometimes no matter how careful you are, you may also mistakenly, you may miss out a particular data. You didn't enter anything there. You jump it. And sometimes it be due to incorrect sensor reading. Maybe it could be due to equipment malfunction, because sometimes we set up sensors in a kind of in an attempt to avoid human errors. This day we go into sensor. We want sensor to be able to pick the data directly from the source. And at that point, there could also be missing value. Equipment may malfunction for a few seconds. It means every data set that passed through at that point in time is not going to be complete. It may be due to sensor, like dirty camera lenses. Yeah, you have taken the picture is not going to show. It means it is missing. And so many other things that could come from the incorrect sensor reading. Sometimes also it could be due to software bugs in the data processing pipeline. Sometimes people set up a data processing pipeline from this stage to another stage. So there could be software bug that it comes from point A before getting to point B and happen, and the data got missing. So this is a possibility. Sometimes when you are inconsistent with other recorded data, so while we are trying to check the quality of our data, we find out that there are some values in the data that are inconsistent. There was a repeated record of the same person, and the date of birth are conspicuously different from each other in these two records. All other things are the same. How do we know what is the correct age? Then deliberately they can delete it. Because now there's no way for them to verify what the accurate age. We can see contradiction in the value recorded in record 1 and record 2. And it is clear that these are the same record, but the age are recorded in a different way. In that case, the data could be deleted deliberately, thereby creating missing value. It's another source of missing value. Sometimes data is not entered due to misunderstanding. So people thought that, okay, it was not necessary. There's no need for us to include this at this point in time. So based on that, people may decide not to enter the data. There's another source of missing data. Furthermore, certain data may not be considered important at the time of entry. During the processing stage, sometimes we don't consider some information to be very important, so we tend to ignore them. But by the time we realize that, oh, we need this data, it may be too late. So at the point of entry, we thought that we are not going to need this data, don't bring it in. But later, when we are going to merge data together, we notice that the data we are merging to, it has this particular feature. Therefore, you are going to have lots of missing data from the other data you are trying to add to the one with missing value. So now moving further, we now say that treating missing data is a fundamental and core element data analysis or machine learning modeling. It's very important to treat missing value. Yeah, it's very, very important. So why is it important? Let's look at it. Why missing value treatment is required. Missing data in the training set can reduce the power or the fitting capability of our model greatly. And sometimes it can even lead to a biased model because we have not analyzed the behavior and relationship with other variables correctly. So, and sometimes also it could lead to wrong prediction or classification, depending on the problem we are treating. Is it a regression problem or classification problem? Let's look at an example to demonstrate why missing value treatment is very important. Look at this example of data set. You can see we have the weight, the gender. Do we play cricket or not? You can see we have male, female. This is missing. We don't know if this person is male or female. So we don't know if this one is male or female. There are two missing there. So if you don't treat it, you are going to find out that when you try to calculate and check who is playing cricket or not, you're going to have wrong information. Because here, you're going to see if we don't treat it, the result with not treated missing value, this is going to result. The difference from this data is that the chances of playing cricket by male higher than female. Because when you look at the check-in for female, we have two females, 1, 2. We have 4. But how many of those female play cricket? Female, only one play cricket. That is 1 out of 2. That is 50%. So male, we have 4 males. How many of them play cricket? Out of those 4 males, we have 2 of them that play cricket. 2 out of 4. Again, you have missing value. There are 2 missing values which are causing this particular problem. So unfortunately, this missing value, you can see here, the missing value here play cricket. Missing value here play cricket. So the percentage of missing value that play cricket is 100%, which is more than the ones that we actually, you can see that it's going to distort the outcome of our modeling. You see? So, however, the same data set, when we decide to treat the data now, we treat the missing value. Then how do we treat the missing value? We get there shortly. So after treating the missing value, you are going to see the outcome. After treating the missing value, we came to know that the missing values actually belongs to female, FF, which made us to now have 4 female, 4 males. However, 3 of those female play cricket, and 2 of them in the male side, they didn't play cricket. So these are the people that play cricket. You see the percentage of those that play cricket female now makes it 75%. 75%. That confusion is gone. So AI will have assumed that he may have that possibility of playing cricket than the female. But however, after taking the missing value, it became very clear who among male or female play cricket most. It became very clear. We said result with missing value, you can see that the female have higher chances of playing cricket compared to the males. So with missing value, we may end up not being able to have correct prediction or classification, depending on the problem we have. And sometimes it could lead to bias. So that is why it's always good. Among the pre-processing activities, missing value happens to be the one that is, we can say, almost compulsory. Very important to treat. While every other ones could be thought of after if the necessity arises. So that is why we need to treat missing value with an hypothetical example. Now, let's look at dealing with missing value. How do we treat this missing value? There are some guidelines that we have to know. See, we first of all have to look at the columns. Usually, we format machine learning data in columns to see. So some of your columns will certainly contain values, which in some cases they may represent it as none. If you are using MATLAB, they represent it as none, which is called not a number, not a number. That is empty column, or sometimes it could be just zero. But mostly it is empty. Very easy to do. So the first thing to check is if your column is having missing value, we can decide to remove that column. However, before you remove it, there is a recommendation to compute the ratio. We call it the missing value ratio. What is the number of missing values and the number of values? That is, in a column with maybe, how many data sets do you have? You have like a 500 sample, the entire data. So number of missing value in one column, maybe column X1, it has like 15 missing values. So 15 divided by 500. This is going to give you that particular missing value ratio. Call it RM. You can put the RM as a guide if I need to remove that column or not. Because this is one of the ways of treating missing value. If the ratio is considerable, then we might have to remove it. We say if RM is high, you may need to remove the whole column. If it is high, you may have to remove the entire column instead of try to complete. However, if the RM is reasonably low, in order to avoid losing data, you can input the mean, the median, or the most frequent values in place of the missing value. You can use any of the imputation methods to solve the problem of missing value. So removing the AO column, for example, I have data set with more than 70 columns, more than 70 features. And there's a column with out of 500, having like a 200 missing value out of 500. Definitely, this is too much. I can drop that column, provided other columns are not having problems. However, sometimes we might have problems that we have situation whereby the number of features you are having, they are very few. Imagine having only 2 features in the data set. And one of these 2 features has missing value that are many. You can't just remove it because you have only 2. Removing it means you'll be left with 1. Of course, you can use only 1 feature to predict. We've done that before and with very excellent outcome, but very rare. So you need at least minimum of 2, 3, 4. However, if you have only 1, why not? You can try it out. If that feature is very strongly correlated with what you are looking for, you may be able to get better results. So what in essence, what we're saying is if the number of features are very few, then you might have to start thinking of not removing that column. However, if you have alternatives, there are many features, instead of keeping a column with several missing values, just delete that column. Otherwise, you can go with the other method of dealing with missing value, which we are now going to consider. Methods of dealing with missing value. So, first and foremost, the best is to get the actual value that was missing. The best way for you to deal with missing value is to get the actual value that went missing. That is, we go back. We need to go back to data extraction and collection stage and then correcting possible errors during these stages. This is the best method. If somebody asks you in an interview, the best way to treat missing value is to go back to the actual where they entered the value. Let them check it and double check. Is this person really male or female? Instead of trying to make a guesswork by treating it, get back to the original source. This is the best way because machine learning model wants you to use a data that is closest to the original data set. So if you can go back and get the original data from where the data came from, this is the best. You see, unfortunately, as great as this option looks like, it's almost impossible. In most cases, it is impossible to go back for many reasons. Imagine you got the data online and there are many missing values. How do you go back? Where do you go back to? The people who put it there, they are going to go back and start looking for the missing value for you. If they have it also, they will have put it earlier. Sometimes the people who even enter the data, they are not more available. When you send back to the people who help you to collect the data, say, oh, it's too tedious. The people who work on this data, they have resigned, they have changed job. You just have to find a way of using what we have. So for whatever reasons, it is usually mostly impossible to go back and get the missing value, even though this is the best method of treating missing value in our data. Because we said earlier, if we remember, we said a smart feature better than looking for smart algorithm. That is, by smart feature, we mean data that is smart, data that is original, that is error-free, that is closer to the reality, is better than looking for smart classifiers to deal with it. Therefore, we always want to have the original data as much as possible. But in real life, sometimes we cannot do without it. When we have missing value, then we have to now look at, okay, if going back to the source not a possibility, then how do we solve the problem? There are two main techniques to treat missing data. Two major techniques. The first one is deletion. The first one is deletion. So you delete the data that is missing. Either by deleting the column, there are two ways to this. We mentioned earlier that we compute the missing value ratio. So if you notice that the deletion really worth it, you can delete by column wise. You delete that feature, kick it out. You have X1, you have X2, and you have X3. And then this is X1, X2, X3. And there are so many missing value here. So we calculate it. If we feel the missing value is very high, then we can delete this column. We don't want it. This is deletion. This is the next, going back to the original source. If going back to original source is not possible, then deletion is the next. You delete that column because you can't get enough data. And sometimes the missing value is not only in that data. It could be one record that is actually missing. One record here. It has missing value here. Missing value, missing value. Then you delete that record. That is row-wise. You delete the entire record here because this one has missing value or 2. Or out of 3, it has only 2. And you have so many samples. Imagine you have like 5,000 samples that I'm working with. And there's one sample that is having missing value in out of 3 columns, is having missing value in 2. I can kick it out because I have enough data to still do my modeling. Because every missing value will potentially corrupt your data and confuse your system. We want to deal with them in a safer way by removing those rows, those records. However, in some situations, maybe the number of rows you're having is so limited. Imagine somebody in material science is having only 15 samples. When you're having 15 samples, 15 is not even enough for your modeling. How can you remove one out of that 15? It's not possible. Just like when your features are very few, you may not be able to remove any feature. However, for feature, it is still good. Even when you can keep removing it. If I have too much missing value, I can also remove this second. I'm left with only one feature. You can do modeling with one feature. That is fine. Like I said, we've had a case of like that in soil contamination modeling. We were able to get very excellent results with just only one feature for prediction. So even one feature, you can still use it. However, when it comes to the samples, you can't do that. The more the number of samples you have, 1, 2, 3, 4, 5 down, the better for your modeling. So when you have only 15 and now you are removing one, maybe you still remove another two. No, your data is getting really extremely fewer that it may not work. So in that case, we have to move to the second method of submitting value treatment, which is called the imputation method. Imputation method. This is what majority of people are usually faced with, because removing features maybe is not an option. Maybe deleting samples also is not an option because the samples are very few. And the best method of going back to the source is not also an option because the people that produce the data says we are not ready to waste our time on that. Our staffs are busy, they are busy on other data collection, so forget about it. Go and deal with it. So we have to go and then use other methods of missing value treatment to solve this problem. Among these missing value treatment, what they are replacing with mean or median. That is, you look for the mean of that column or median of that column or mode of that column. Mode means the number that repeats itself mostly. You can use it to replace the missing value, the one that occur mostly, or calculate the mean. This is one. In that case, we can look at the case we have here now. If you want to treat this one, you can see the mode here is 1, 2, 3, 4. 1, 2. So the mode is M. We're gonna be fixing this one for M. This will be M. This will be M. And this also will be M. Even though now we can see that it's not correct. This is the challenge of missing value. If we fix this by using mode, we are not going to be correct because the actual correct thing is actually F. So the best way is to go back, but sometimes when we don't have option, we go for this imputation method. So it's the last option actually to go for. You have to check, can I delete the column? Can I delete the row? If you can get away with those records that are having missing value, it's better for you. Especially if you are lucky and you have a lot of samples. You have like 1 million samples. Even if you remove 10,000 missing samples with missing value, that's okay. Because we want the original data as much as possible. Imputation may actually be that you are inputting a wrong value. So we don't trust it. And that's why I just gave an example now. If we follow the mode example here, we're going to see that we will be replacing them with M, male, male, even though the correct answer is female. If we go back to the owner of the data, this is the challenge of imputation. It's usually a last option. So also you can assign a unique category. You assign a unique category. So it means you look for a particular category that does not even present. You see, we have two classes of students, good and bad students in that classification problem. But one is there's a missing value. So we can create a new category of student unknown. Unknown, that's going to be a unique category. Unknown, that is, we don't know whether it's bad or is good. You create it as a third value in that particular column. And then you may also assign a most frequent value. That is, most frequently used value may be assigned. And in another case, we may also use algorithms that support missing values. Missing value. It means we use predictive algorithms also enter the value that's supposed to be there. So what we need, because of our time, we are going to look into this treatment, method of treatment in detail in our next session of our meeting. So we're going to look at replacing with missing value, mean, median, with practical examples, assigning a unique value, unique category, assigning most frequent value, and also how do you use algorithm that support missing value? Which algorithm support missing value, and how do we use it? So this is what we are going to be looking at in concluding the method of dealing with missing value by the grace of God in our next episode. So thank you very much for listening. Thank you.